Hello, this time we will introduce powertrain operating modes and show their relation to vehicle modes. First we need to define the powertrain modes, which is very simple. The powertrain is in traction mode when the traction force is positive, in coasting mode when the traction force is zero, and in braking mode when it's negative. Traction mode is when the engine or electric motor create a force to propel the vehicle. For a combustion engine powertrain, coasting mode is typically achieved by disconnecting the engine from the wheels with the clutch, or in an electric powertrain by making sure that the electric motor output torque is zero. Braking mode is when the brakes are activated, or during engine braking, or regenerative braking using an electric motor. Note that most powertrains are in braking mode if the accelerator pedal is released, even if the brake pedal is not pressed, either due to losses in the engine or due to regenerative braking from an electric motor. The reason why we spend some time discussing the powertrain modes is that they often are confused with the vehicle modes. For example, it is often assumed that braking must lead to deceleration, which is not always the case. This is easiest seen if we use the running resistance diagram again. Here the running resistance curve is plotted for a flat road. Since we have derived when the vehicle accelerates or decelerates, we can plot that in different colors in the diagram. Braking mode is when the traction force is negative. In this case, we can see that on the flat road, braking mode always leads to decelerations, since in all speeds and for all negative values of traction force, the vehicle decelerates. Coasting mode is at zero force. Also for coasting mode we can see that it always leads to deceleration on this flat road. Traction mode is all positive forces. But traction mode is more complicated if the traction force is low, like 500 Newton. At low speed, 500 Newton will lead to acceleration. And if the speed is increased, the same force would lead to a constant speed at about 120 km per hour for this vehicle. And at even higher speed, the same force leads to deceleration due to the higher aerodynamic resistance. So on a flat road, the vehicle can be both accelerating, keeping speed, or decelerating when the powertrain is in traction mode. The result on an uphill road is very similar as for the flat road. Braking and coasting always leads to deceleration. Traction mode can again lead to all three vehicle modes, but the traction force has to be much higher to result in a constant speed or acceleration on an uphill gradient than on a flat road. The result on a steep downhill gradient is different. If the powertrain is in traction mode, we almost always get acceleration on the downhill gradient, like in this example. But very high speeds in combination with low traction force can result in deceleration. In this example, the speed needs to be 190 km per hour before a positive traction force can lead to a very small deceleration. Coasting in this downhill gradient almost always leads to acceleration, except at the highest speeds. On a downhill gradient, braking can result in acceleration, constant speed, as well as deceleration. To summarize, there are some important things to remember about powertrain modes. First, traction mode is when traction force is positive, coasting when it's zero, and braking when it's negative. Second, traction mode is only saying something about the size of the traction force and not whether the vehicle accelerates, keeps the speed, or decelerates.